The objective of this lesson is to compare two fractions by considering the size of each fraction in relationship to 1/2. Let's create a list of fractions equivalent to 1/2. 2/4, 3/6, 4/8, and 5/10. Notice that each fraction equivalent to 1/2 has a numerator that is exactly half the denominator. We can use this idea to identify additional fractions equivalent to 1/2. For example, 12/24, 23/46, or 75/150. Given that we can identify fractions equivalent to 1/2 by looking for a numerator that is half the denominator, let's determine whether a fraction with an odd denominator can be equivalent to 1/2. To do this, we will look at thirds and fifths. 1/3 by itself is less than 1/2. It is exactly half of 1/3 less than the 1/2 size piece. In other words, if I take 1/3 and a piece half its size, they combine to be equivalent to 1/2. 2/3 is more than 1/2. It is exactly half of 1/3 more than the 1/2 size piece. In other words, if I take 1/2 and a piece half the size of 1/3, it is equivalent to 2/3. Since 1/2 lies in between 1/3 and 2/3, we cannot create a fraction using thirds with a whole number numerator that would be equivalent to 1/2. Similarly, 1/2 lies in between 2/5 and 3/5, meaning we cannot create a fraction using fifths with a whole number numerator that would be equivalent to 1/2. We can use the fraction 1/2 as a benchmark fraction when comparing the size of other fractions. It is also helpful as a reference point to make estimates and to assess the reasonableness of answers to calculations. It becomes like a mathematical landmark we can use when working with fractions. As we begin comparing fractions to the 1/2 benchmark, it is important to realize that many students may continue to benefit from using manipulatives when working with fractions, while some students may prefer to work with mental models or logical reasoning. Both approaches are appropriate at this time. If we were to compare 4/5 to 1/2, we could use our fraction manipulatives to discover that 4/5 is greater than 1/2. We could also reason that since the numerator of 4 is greater than 1/2 the denominator of 5, the fraction is greater than 1/2. Comparing 5/12 and 1/2, we can again model them visually to see that 5/12 is less than 1/2. Similarly, we could determine that half of 12 is 6, making 6/12 equivalent to 1/2. And since 5/12 is less than 6/12, 5/12 is therefore less than 1/2. We can use the same process to compare fractions when one fraction is equivalent to 1/2 rather than stated as 1/2. For example, 4/8 compared with 2/3. We can identify 4/8 as the fraction equivalent to 1/2 since the numerator of 4 is exactly half the denominator of 8. 2/3 is greater than 1/2 since 2 is greater than half the denominator of 3. Since 2/3 is greater than 1/2 and 4/8 is equivalent to 1/2, 4/8 is less than 2/3. The process becomes a bit more involved when comparing fractions when neither fraction is equivalent to 1/2. For example, 7/8 compared to 2/5. Of course, we can still use 1/2 as the benchmark to compare each fraction, giving us a common point of reference to make our comparison. We can see that 7/8 is larger since the numerator of 7 is larger than 1/2 the denominator of 8. 2/5, by contrast, is less than 1/2, since the numerator of 2 is less than 1/2 the denominator of 5. Since 7/8 is greater than 1/2 and 2/5 is less than 1/2, 7/8 is greater than 2/5. We can also see this visually. We can follow the same process with 9/5 compared with 3/8. 9/5 is greater than 1/2 since the numerator of 9 is greater than half the denominator of 5. Alternatively, we know 9/5 is greater than 1/2 since it is also greater than 1 whole, the numerator being larger than the denominator. 3/8 is less than 1/2 since 3/8 is less than 4/8. 4/8 is the fraction equivalent to 1/2. Since 3/8 is less than 1/2 and 9/5 is greater than 1/2, we can use 1/2 as the common benchmark between them and identify that 9/5 is greater than 3/8. The objective for this lesson was to compare two fractions by considering the size of each fraction in relationship to 1/2. We met this objective by discovering a shortcut to identifying fractions equivalent to 1/2, and then using 1/2 as a benchmark. We identified fractions greater than or less than 1/2, and used that comparison to draw a broader conclusion about the size relationship between two fractions.